Hello coders, welcome back to another live coding session where we tackle a new Leetcode challenge. Let's dive in and decode some problem together. Last time we inverted binary tree. This time we calculate probably. Yeah, we will calculate maximum depth of binary tree. Did I solve it? Yes, before? No. So given the root of binary tree, and we need to return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. Okay. How can we solve it? Which approach can we apply here? Can we skip some nodes? Probably not. We need to check traverse each node until we calculate each node's depth. Yeah, depth until we calculate all nodes length, depth, and after it we can return the max depth. We can declare variable for max depth, and we can traverse through. Yeah, we can traverse through tree until we traverse through whole of the tree and calculate depth of each node. If depth of some node is more than max, then we rewrite max. We update max at this point. So we have traverse method, which would be some function, function node and callback, which we traverse root callback, some callback. Sorry, I'm confused. I forgot. Here we need to write our callback, but here we just invoke it, call this callback. So if no node, return callback node left, callback node sorry, I'm confused again, but how I make recursively. We invoke callback on node itself, then traverse to its left subtree and traverse to its right subtree. Yeah. So here is our traversing algorithm. We can move it to the top, outside of, on the module level. And now we need callback. Callback is the node. It could be function. If node val. Node val, not value. Oh, not value. I need to keep the depth of each node somewhere. But where? Where I can keep the depth of node. Probably in value. But how can I pass previous its parent's depth? I need to pass it somehow while traversing, like depth plus 1 depth plus 1 and pass it to callback. Is it okay? It is number of nodes, so the initial depth is 1. Yeah. Callback get depth. So if depth more than max, then max would be depth. That's it. And return max. Probably it's enough. Too much parentheses. Wrong answer. Expected 3. Three, 9, 12, 15, 7. Why it's 2 but not 3? Max is 0. not in case 2, yeah. I missed something here. So let's try to debug it in my mind. We invoke on the root node with callback. Root node is not empty, so we invoke callback with root node and depth equals 1. So root node, we even don't need a root node. 1 is more than max. Yes, max is 1. Okay. Then we invoke it for 9 and 12 with depth plus 1 is 2. We go to 9, we go to 12, we invoke on 9, it become 2, max become 2, then we invoke on 12, oh sorry, 20, on 20, 20 and depth is 2, is already replaced, then updated, max already updated when we was on 9. Okay, then we move to the left subtree and right subtree. Probably it is, yes. Again, it's misspelled with the word right. R-I-G-H-A-T. Is there any highlighting? No. So it works. Let's submit it. Yeah, it works fine. Even more. We can replace recursion with queue or stack, but I think it's not necessary because previous time I already did those approaches, and it was pretty similar. Let's watch other users' solutions. Recursion. So C++, recursion, max depth. Max left, max right plus 1. If root, not root, return 0. It is another approach. You get until the leaf, then assume that it is 0, then start to go back with in recursion. Probably it's not the best, but it works, yes. But it could produce memory leaks because you need to go back in your recursion. You need to reach the each leaf, then go back in your calculations, returning this one, calculating depth. Num of nodes, space height of the tree. I couldn't calculate these things. I need to learn how to calculate it. Probably I'll try. I try. So what do this approach which I use? It goes through starting from the root until the last of the tree, and it doesn't go back. So the how we can name it, complexity, time complexity is O n, number of nodes, yes, O n, and space complexity, space, do we need additional space? No, we have only one variable. We have depth, two variable, and space complexity is O1 because we don't need recursive stack, or we need it. I don't know these details. Probably because of the recursion, it should be height of this tree. It is. My algorithm is O height of the tree. Let's watch other approaches. For example, is there any stack or queue? Yeah, monotonic queue. What is this? So we have queue, we push their root, and why queue is not empty, we take items from queue, and it is not declarative much, but it working. We increase height each time when we, yeah, it's depth first search, so each time we traverse one level of tree, so we go through this level, put next level nodes to the queue, and increase height, and we do it until we get an empty queue. Monotonic queue and stack. Is there stack? No, yeah, we have stack. How can we use it with stack? Probably the same as queue. Helper root depth. What is answer? Return. Until we get. It's similar with the one which I use. Bottom. It was recursive top down. Yeah. And there is iterative. I'm interested in iterative. So initial answer is 0. Parent. Oh, whoa. Oh, why so complicated? So we have parent length. Root and its height. We take something, nodes temp 0 and 1. I don't get it yet. So while parent length. While parent length. What is the parent? Is there any approach? Is always easy to understand. I'm not agree. Recursive top-down is understandable for me because it's the same with my solution. Bottom-up. Yeah, it's similar, but iterative is not. Let's try to start from the end. Probably I will understand. Yeah, we have children. What is the children? Children, we push their left and right subnodes of each node. Parent push children depth +1. What is parent? I don't know. It is some list of the nodes and its depth and level on which their and their level, a number with their level. Nodes, it's the first, depth is the second item, so it's the pair. Actually, we work with pairs. I see. And we go through all the nodes, and if it is the leaf, then we update our answer. If not, we take child nodes and push them as pairs and push them as pair and push them to parent array named parent. I see. Pretty similar as queue approach, but more complicated. I don't know is it okay or not. Okay. So I think that's it for today, for this time. Thanks for coding along with me today. And remember, practice makes perfect. Keep solving and see you in the next session.